Okay, students. Last class we had seen the problem, right? The last one based on molality. You all understood that. You all want me to repeat? Should I explain it once again? I'll explain. Okay. So I think it was question. What was the question number of that? 20, 21, no? Yeah. Okay. Any doubt? Okay. So the question says the density of 3 molarity of solution of NaCl is 1.25 grams per ml. And we are told to calculate the molality. Okay. So how will we do this problem? Just open this new marker and it's not working right. Okay. Question 21. So what are we given? We are given molarity, no? That is 3 capital M. So capital M is basically for molarity. Okay, R. Then we are also given the density. That is 1.25 grams per ml. You all can see, or should I change the marker? You can see, right? Okay, so now, what is the formula for molality? Number of moles of solute. So in this case, it will be NaCl upon the mass of solvent in kg, right? Okay, so now what do we have? We have molarity. Okay, so we know the formula of molarity will be number of moles of say a solute divided by the volume of solution in liters. Okay, so we know this formula. So what are we given? We are given molarity. Okay, so since we are given molarity, let us substitute this 3m here. Okay, so basically your molarity is 3 and we have to find the number of moles of NaCl. Okay, so this we will consider it as X. Okay, so volume of this solution, right? Like in standard conditions, we take as 1000 ml. So 1000 ml will be equal to 1 liter. So since we take 1000 ml, so because of that, we take here as 1. Okay, so your X will be how much? 3 moles, right? So your number of moles will be 3. Okay. So now we have found this. Okay. To substitute the formula, we need 2 entities, right? First one is number of moles of NaCl. That we have found. Now second, what is remaining? The mass of the solvent, right? That is in kg. So now what are we given? We are given density. Okay. And we know, like, we can't directly find the mass of the solvent. So what will we do? We know that if you have solute plus solvent, we get solution. Okay, this concept we know. So now what we will do is in order to find the mass of a solvent, we will find the mass of the the mass of the solute and the mass of the solution. So both these parts will find out, and then we will subtract the solute from the solution. So that will give us a solvent. Okay. So here we are given density. Okay. So using the formula, or like using density is equal to mass upon volume, which which part we can calculate? Can we calculate the solvent, the solution, or the what? Using density, okay. Still, actually, you're confused, okay? Just understand, using density, okay? There are two formulas. See now, to find the mass, okay, mass of any substance can be found using two formulas, no? Basically, one will be density is equal to mass upon volume, okay? And the other one will be what? Number of moles. So number of moles will be equal to given mass upon molar mass, okay? So we have two formulas. So I am asking you, like, which formula will you use for which part? We have three parts now here. So I want you all to tell me that this formula, we have two formulas. First is density is equal to mass upon volume. So the density formula, for which part you will use? Solution, right? Why will we use for that? Yes, right. All have understood this. So density, it can't be for solute, okay? It can't be, okay? Density basically tells us how dense that liquid is. So density will always be for liquids, okay? It can't be for solid, okay? So because of that, we say, so we will find the density. This part will be of a solution, okay? So this has in turn two parts. So first we will try on solving the first part. So what is the density? Okay, so we will rearrange it. So if we rearrange, density will be equal to, meaning mass will be equal to density into volume. Density we know it is 1.25. And volume I had said we have to take it standard, right? So I had said in the previous case, what do we take it? 1000 ml, okay? So in this case, for now, we won't convert it into liters, okay? We will keep it as ml only, okay? You all will understand it why I'm keeping this as ml only. I'm not converting it. I'm just keeping it as 1000 ml. So this will be 1000. So how much it will be? 1250, right? All agree? This will be kg. Okay. So now let us move on to solute. Okay. Finding the mass of the solute. So, like, what do I have to find the mass here? Number of moles. From where did I get number of moles? From that molarity formula, right? So what will I do? I will substitute this. I will rearrange first. So this will be given mass, okay? And this will be number of moles into your molar mass, okay? Or molecular mass. So number of moles are 3 into your molar mass of NaCl will be Na, no, will be 23, and Cl will be around 35.5. Okay. Suppose if I take sodium, it is 23, and the atomic mass of chlorine is 35.5. So basically, we have to add both. So after adding, I feel 58.5, right? So 3 into 58.5, that will come to 175, 175.5 grams. Okay. Till here, all I've understood. Sure. You all have any doubts? Now what will I do? Now I will find the mass of the solvent. So basically, mass of solvent will be equal to mass of solution minus mass of solute. Okay. So what will be the mass of my solution? 1250 grams minus mass of solute will be 175.5 grams. Okay. So I will get the answer as 1074.5 grams. You are getting something like this. Yeah. So now I want to convert grams to kg. What will I do? Divide by 1000, right? So what answer I will get? 1.074 kg. Hmm? So now we have found here, first we knew the number of moles, right, of NaCl. Now we have found the mass of the solvent in kg. Okay, fine. Okay. So yeah, so now basically what we will do is we will substitute this and this 3 moles in our equation. So what it will be, I won't write it again. Okay, I'll just substitute it here. So it will be 3 upon 1.0745. Okay. So that will come to 2.79 m. Why small m? Molality. Okay. So for understood, any doubts? Sure. If you all have done, if you all have understood this, right, and copied, I want you all to solve the 22nd one. I want you all to try this time. Yeah, okay. So for the 22nd problem, right, the molecular formula of glucose will be C6H12O6. Any doubts? How you always approach? How you always start the problem? Okay, I'll give you all a hint, okay? It has something to do, starting of the problem, it has something to do with mark percent. You are given the percentage, right? Yes. So in that way, you have to find out solvent and all. Accordingly, then proceed with the problem. Understood? So not here. That it is given, see, percentage is given, right? Like glucose, I think 10%, 10% of glucose, okay? So it has something to do with the mass percent. I thought the problems, right? Like the mass percent, like your, like 10% will be what? 10 grams of your solute, okay? So 10, suppose your solute is 10 grams, what will be the solvent? Hmm? If, see, if I have 10 grams, if I have 10%, okay? If I say 10% of glucose solution, okay? So what does this mean? 10 grams will be your solute, okay? Then what will be your solvent and what will be your solution? 90, right? You understood 90, right? So solvent will be 90 and the solution will be 100. Good. You understood? Hmm? Okay, so now what does the question say? It says our glucose solution is 10%, right? So I thought last time I taught you all mass percent problem C's. So when I say 10%, what information do you get when I say 10%? Solute will be 10 grams. Okay. Now here, this also is important. Okay, weight by weight. Meaning what it says, like I said, the numerator and denominator. Okay. Like both, suppose if I say weight by weight, meaning both will be in grams. Okay. So suppose if I say, suppose this question says 10%. So when I say 10%, it means that 10 grams will be your solute. Okay. Then remaining 90 grams will be your solvent, and the total 90 plus 100 grams will be your solution mass. Okay. So now you got a hint, right? So now like it says to calculate the molarity and mole fraction. Okay. So now it will be easy for you to calculate all three. You understood how to approach the problem. I given an hint. You'll understood that hint which I gave. 10% meaning what? Solute will be 10 grams. And if you know that 90 grams will be your solvent. And total 90 plus 10 will be your solution. Okay. So you understood this, no? You did not understand. See now what the question says. It says that a glucose solution is 10% weight by weight. Okay. So like first, when I explained the mass percent, right, I had explained three parts here. One was volume by volume, the other one was weight by weight, and the other one was weight by volume. Okay, this three. So this is one of those three which I had explained. Okay, weight by weight. So what information this 10% will give you now? It says that glucose solution is 10%. So, like, what do we know with this 10%? That your solute will be 10 grams, no? Okay. See, now suppose if your solute, then, see, when I say 10% of any solution, okay, and you're given weight by weight. So what information do you get from this is, I say that basically, and here they have mentioned a glucose solution is 10%. So basically it will say that your 10% will be your 10 grams will be your solute. Okay. Where your 90 grams will be your solvent. Okay. And your total, like 90 plus 10 will be 100, right? So 100 grams will be your solution. Okay. So with this information, now I made it much easier for you to like this what this 10% makes. Okay. So now what you can do is now you can write like first what they have said, they have told you to find the molality, right? So what is the formula for molality? Number of moles of your solute upon the mass of the solvent in kg. So how will you find the number of moles now? Which formula do we know? Number of moles is equal to given mass upon molar mass. Okay. Ata, let's see now. Now, number of moles will be of your glucose, right? Basically. So now we know that 10 grams. So your solute here is what? Huh? Yeah, mass. But of what? Like here we have two entities. One is water and the other one is glucose. So which will be your solute in this case? Glucose. Okay. So number of moles will be of glucose. So now will you not be able to find because the number of glucose is equal to given mass upon molar mass. 10 grams, 10 grams will be of glucose, right? So take 10 grams upon calculate the molar mass of your glucose. Okay, so that will come to 180. So take like that. Then from there you will get your number of moles of your solute. Okay. Substitute the number of moles in that molality formula on top. And down what they have asked, mass of your solvent in kg. So you know the mass as well. Mass is 90 grams, no? So basically, if you want to go from grams to kg, what you will do? Divide by 1000, right? So you will get 0.09 kg. Okay. So then you will find. So same way, write the formula of molarity next and see what molarity requires. Okay. So from here, take that into the formula. Simple, right? You understood, right? Number of moles. Okay. So now what you have done? You have just started know this. So now, which formula do we know for number of moles? Just one formula, right? Number of moles is equal to given mass upon molar mass. Okay. So now this 10%, I distributed that. I told you that 10 grams will be of your solute, right? So what will be your solute in this case? It is glucose solution. So you get a hint key. In this, there will be two entities. One will be water and the other one will be what? Glucose. So what will be your solute in this case? Glucose, no? So what number of moles of whom you will find? Glucose basically. So number of moles of glucose is equal to given mass, that will be 10 grams upon the molar mass. If you calculate, it will be 180. It will come to 180. Okay. So if you have calculated the number of moles, you can substitute in the formula molality. Solvent mass of solvent is 90 grams. 90 grams. Yeah. But you require in kg 0.09 kg. Okay. Accordingly, do it for molarity and mole. Yeah. Okay. Okay, so the answer you're getting to 90 is 90. Molality you have calculated first, no? Molality is 0.61, right? The second one will be 93.3 ml, the volume. Oh, no, no, yeah, the final volume. You can use think log down. You all have no option. No, you all can't even use a small calculator. I think for practicals you can use. For practicals allowed. Practicals also not allowed. It is allowed. So you all can use for in the class also small calculators. Yeah, only for practicals. 93.3 ml. You very like systematically, like right? Very systematically, and also no, don't miss out on writing the formula. Okay, now it is fine because if whatever your teacher will cut marks. Okay? So you all have reached. Okay, so what do you mean by this 10% of solution, glucose solution? Hmm? Tell. Basically, if I say 10% of glucose solution, what do I mean by that? 10 grams will be of solute, right? Then the remaining 90 grams will be solvent. Okay, and the total will be solution. Okay, that will be 100 grams. So this information we get from here. Okay. So now what you need to do is you need to write your formula of molarity first. Okay. So what does it say? It says number of moles of your solute upon mass of your solvent in kg, right? So for that we require number of moles. So how will you find number of moles? Number of moles is equal to given mass upon molar mass. So number of moles will be of whom specifically? Of the solute, right? In this case, what is our solute? Glucose. Okay. So now what is the mass of our glucose? 10. 10 grams upon molar mass will come up to 180 if you calculate C6H12O6. If you substitute all the atomic masses, right, you will get 180 as the mass, molar mass. So that you will substitute, you will get the number of moles. Then substitute the number of moles in this equation. And then what will be the total mass of the solution, no, of the solvent in kg? Solvent is how much? 90. But we have 19 grams. Okay, so suppose if you want to move from grams to kg, what you will do? Divide by 1000. So you will get it as 0.09 kg. Okay, substitute that, you will find your molality. Okay, accordingly, do the same thing and find for molarity. Where you people have reached? Why are you finding mass? So for this one, you're finding. No, you found the like you use the formula, right? Density is equal to mass upon volume. Like for what like you have used this to get mass? Mass person. Huh? Mass of solute? No. What did I say at the start? What hint did I give? 10%. So what do you all understand by 10%? Weight by weight. Okay. So if I want to split that 10%, what will I do? 10% will be 10 grams of solute. Yeah. Glucose. Okay. 90 will be what? Solvent, no? Solvent. And a total 90 plus 100 will be your solution grams. Yeah. So here weight by weight clearly tells you that all this whatever you distribute, right? 10 grams, 90 grams, 100 grams, they all are in weight by weight, meaning in grams. Totally, okay. So here you will get your solvent, solute, everything the weight. So this that 10 grams where you can use in your number of moles. Number of moles of glucose will be what? Given mass upon molar mass, right? Molar mass you have calculated. Huh? Yeah. It comes to 0.055. Yeah, 55 something.
Then we got the number of moles.
Yeah.
Of solute.
Mass of salt.
So we got the number of moles.
What are you calculating here?
Of solute.
No, what? Like molarity. Molarity.
B, smaller. No, B.
Molarity. Riti. So for what two things you require? Number of moles of your solute upon volume of solution. In liters it says, right? So how will you find your volume here? You know one thing you know, number of moles you know. So how will you find your volume? Density is equal to mass upon volume. So density I think it is given, right? Okay. So mass of your what you will use? Three parts you have. Density, what I had said starting, for what we do. Yeah. Keep that in mind, okay? So from there you will get your volume. Substitute the volume in the molarity formula. The final answer you're saying 100. Solution total will come up to 100. No, 10 plus 90 will be 100. So substitute the volume of the solution. Yeah, 0.055 upon.
No.
Why you got 100 here? 100 grams. Zero. 0.058. Yeah, 59 also is acceptable. Okay. 0.0. No, 0.58. Yeah, right. My bad. Huh? How?
What is this?
Okay, if you divide 18, 1 by 18, what answer will you get? 0.055, no? Like 0.0. I think there you are middle. Do the division again, like 1, yeah. So now what is 0? Point, yeah. No, when you get a. Okay, so then you get a 0 here now. No, it will be 18. Yeah, yeah. 9. Yeah, so now it is 0. 10 was again you have to put a 0 on top. Then approximately calculate 18 5 is what? I think it will be 5 for me. You're getting the right answer. Yeah. 0.0. 5, and then if you want to convert it, yeah, 0.6 something is the molality. 0.61. Yeah, right. It's like 1, 2 here and there, it's accepted. Okay. Now calculate this number here. Yeah, 0.05. Okay. This is right. So this answer will come up to something like yeah, it will come to 0.61. Yes. Use log. Correct. Yeah. Basically 0.05 will be what? You're calculating molality, here. So 0.05 will be what? Number of moles of glucose upon the mass of the solvent in kg. So mass I had said is 90 grams of the solvent, right? So if I want to convert 90 grams to kgs, what will I do? Divide by 1000. So if I divide by 1000, how many 3 places it should shift towards the left, right? So it will be 0.09. Yes, it is right. So whatever answer you get, this will be your molality. Okay. Logbook. So you can leave some space like for that. Yeah, it's still not done. Like this, you all won't even finish the paper, I feel. Some people have done. Yeah.
So what is the
Volume of what?
density?
I want the answer. 93.3 ml. Density is equal to mass upon volume. Mass will be of what? 100. Right. So suppose if you divide whatever your 100 by 1.072, how much you will get? 93.3. Done? Okay, this is done. So now, how will you calculate for molality? What's the formula? Molality is nothing but the number of moles of glucose, like the solute which is there, upon mass of your solvent in kg. Okay, so now you have already found one entity, the number of moles you have found. So now what is remaining? Mass of solvent in kg. Okay, but you have to find, yes, right. Okay, so here you cannot find, just have to convert it, okay, grams to kg. So you have to substitute, like basically in that formula. So you get 0.055 divided by 0.09. That will be your molarity. Okay. Then calculate the molarity and the mole fraction. Now it will be very easy because you have calculated the number of moles, right? So you can directly substitute for mole fractions. Okay. Yeah.
93.93.
Yeah.
Divided by 1000.
Yes.
No, sir. 93. 93. No, 0.93.
What? 0.093.
0.0. This is 0.05 divided by 0.09.
Yeah.
Yes.
Hmm?
Very
You all want me to solve?
Say, please.
Okay. Okay, so now you all have to tell me, okay? I think 22nd one. So now what information do we know? We are given glucose solution is 10%. Okay, I'll just write. Glucose solution is 10%. So what information do we get? That it is
10 grams.
10 grams will be your solute. So what is our solute in this case? Glucose, that is C6H12O6. Okay, this is done. So what is remaining? 90. 90 grams is what? Solvent. And the total will be what? 100. 100 grams will be solution. Okay, done? Now, if I see the molarity, okay, if I see all the formulas, like first one, I'll do it as molarity, okay, that is number of moles of, in this case, it will be glucose, yeah. So you can specifically write of what, okay, glucose upon volume of solution in liters, okay. Next one is molality, number of moles of glucose divided by mass of solvent in kg. Okay, and the last one says is mole fraction. So mole fraction of glucose will be what? Number of moles of glucose upon number of moles of glucose plus water. What? No, I told you last time, right? Like mole fraction, we write like this symbol we represent. Like it is basically X in the form of X, but curved X. Like this and like this. Okay. This is basically, it like saves a lot of time. You all can write also, okay? Mole fraction, you all can write. But here I will stick to symbols, okay? So this is for mole fraction. So mole fraction of glucose is equal to number of moles of glucose upon number of moles of glucose plus number of moles of water, like the total, okay? Next will be of water. That will be number of moles of water upon number of moles of glucose plus number of moles of water. Yeah. Now done. So now you have to check what things you require. First, we require number of moles of glucose. So how will we find number of moles of glucose? Number of moles of glucose will be equal to given mass upon molar mass. Okay. So that will be 10 upon 180. That will come to 0.055 moles. Okay. So now this first part of this both are, we have found number of moles because both the formulas, molality and molarity, requires number of moles. We have found out there. So now what is remaining? For this we require volume. Okay. So how will we calculate the volume? I'll write it here. Okay. So density is equal to mass upon volume. Okay. Now I want to find the volume. So let us rearrange. So mass upon density, right? So mass here, what mass will I take? I have three masses to take. One is 10, one is 90, one is 100 grams. Why do we take 100 grams in this case? Solution, right? Density is always for solution. Because of that, we take 100. Okay. So 100 divided by density was 1.072. Okay. So you get the answer as 93.3 ml. Okay. So basically this volume we have to substitute here. Okay. So number of moles will be 0.055 upon 0.0933, right? So molarity will be 0.58. Okay, if you all get like 0.59 also accepted. Here and there it is accepted, but a very vast difference in the first number just after that decimal point will not be accepted. Like if you all get say 4 or 6, it is like then half mark and all, like a quarter mark will be cut accordingly. Okay, like how far you are from the answer. Okay, so now here it will be 0.055 upon mass of solvent will be what? 0.09 because it is in kg. Okay, 0.09. The answer will be 0.61 small n. Okay. So now how will we find glucose number of moles will be what? 0.055, right? Okay. And okay, and here also it will be 0.055 plus number of moles of water it will be what? For mole fraction. Think properly and then, think. Hmm? You are telling me the answer. Yeah. Number of moles of water is 5. But how will I calculate? I'm asking. You're right, 5. So how will I do? Same thing I will use, right? For number of moles of water, it will be given mass upon molar mass. So what is the given mass? 90, right? Why we took 90 and why not 100? Water. Yes, right. And down will be what? 18. So this will come up to 5. So plus 5 and here also it will be 5 upon 0.055 plus 5. Okay. So for glucose it will be 0.010 and for this it will be 0.99. Okay. If in case you all want to skip all this, right, because this is a bit like tedious step. Huh? No. I'm just telling you all. I have last class I had explained you all two ways, right? Either you all can, like do find the number of moles separately for water and for glucose, or else the other one how you all can find, you all have to find only of one, like the mole fraction of one entity. Like for example, if you all find of glucose, so what you all have to do is the mole fraction, whatever, of glucose plus the mole fraction of your water will be equal to 1. So basically, you can do 1 minus your glucose. Okay. Then you will get your mole fraction for water. This also can be done, or you can do this separately and show like your 5 upon total, adding all the moles of number of moles of both the entities. Okay. Understood? Any doubts? This side you all have understood how to find the mole fraction. You have understood? Okay, if you all have understood, no? Take. And last time, like Sanvi had asked one, like you had said something, see that I think I had missed out. Like I just, I did not read that both, like was solvent or solute, I think. I don't know where's it. Which question it was? Question 20, so it says 2 moles of your solute B is mixed with 3 moles of solvent A, okay? So keep that solvent A like that only, okay? I thought that the solute B is the solvent, so I got a bit confused. Okay, so keep that question like that only, don't change anything. Well, you all had not changed. Okay. Done? Okay, if you all are done with this note, take the next one for homework, that is question 23. That is the solution is prepared by adding, no? I feel that one. But here, just take the density of ethanol as 0.789 grams per ml. Okay, just I want you all to write this. Density of ethanol, take it as 0.789 grams per ml. Okay, for the question 23rd, which you all have taken for homework, right? For that, just write the density of ethanol as 0.789 grams per ml and density of water is 1 gram per ml. Density of water is always 1. Yeah, this is the symbol for density. Okay. Dan, you all made a note, right? Density of water and ethanol. Now we will go on to the last part, that is how to calculate the empirical and molecular formula. Okay. Do you all have any idea what do you understand by both the terms? Okay. So suppose if we have the empirical formula, okay, and the second one is molecular formula, okay. So what do we understand by both? Basically, the difference between both is empirical formula will tell you. Okay, so I saw that you're telling me like, okay. So empirical formula will basically tell you like which elements are present, okay, in that particular compound. It just gives us like which elements are present. Okay. But your molecular formula will be more precise. Okay. It will tell you all how many like moles of that particular element is present. Okay. For example, suppose if you have a formula, same, take the formula of glucose, okay? C6H12O6, okay? So if you find the empirical formula, it will tell you precisely like which elements are present, like your carbon, hydrogen, oxygen. So you'll get a brief information ki which elements are present, okay? But empirical formula will be precise in telling you which particular elements are present, okay? But molecular formula is one step ahead. It will tell you the exact number of elements which are present. Like here, 6 carbons are present, right? So, like molecular formula will tell you 6 number of carbons are present, 12 hydrogens are present, 6 oxygens are present. Okay? So the only difference between empirical formula and molecular formula is empirical formula will only tell you the elements which are present. Okay? But your molecular formula will tell you the number of elements which are present in that particular compound. Okay, so the difference between both of this is only this much. Okay, so basically your molecular formula is more precise compared to your empirical formula. Okay, so now let us take the question. I think 24. The thing is, I did not write the question number, so it becomes a problem. Which one is question 24? Okay, yeah. So question 24. So what does this say? This question tells us the compound contains 4.07% of hydrogen, 24.27% of carbon, and 71.65% of fluorine. Its molecular formula is 98.696 grams. Okay, and here we are told to find the empirical and molecular formula. Okay, so we will solve this using a table. Okay, so it becomes very simple. Suppose if you are calculated individually, right, it becomes like very lengthy and a mess basically. Yeah. So we will solve using a table. First column will be elements. Okay. Second one will be percent by mass. Third one will be atomic unit. Next one will be atomic ratio. So atomic ratio will be equal to percent by mass upon your atomic unit. Okay, and the last column will be simplest ratio. So far 5 columns. Okay. So here in the question, which elements are we given? We are given hydrogen, then carbon, then chlorine. Okay. What percentage of these elements are given? 4.07% of hydrogen. Carbon is 24.27 and chlorine will be 71.65. Okay. Atomic unit is nothing but atomic mass. Okay. Okay. Atomic unit is nothing but atomic mass. So what do you know? Like atomic mass of hydrogen will be what? 1. Carbon 12. And chlorine will be 35.5. Okay, some take it as 35, some take it as 35.5. But this will be given to you, the start of your problem or the start of the page, like starting. You start with the paper there. So here for atomic ratio, what does this say? We have to take percentage by mass, meaning this entity divided by your atomic mass, right? So what it will be? 4.07 divided by 1. Okay, so this will come up to 4.04. Okay, 7. Since we are ignoring that 1.008, right? So it will be the same thing. Then will be 24.27 divided by 12. Okay, so the answer will be 2.02. And the last one will be 71.65 divided by 35.5. So that will be approx 2.02. Okay. So now till here all have understood. Okay, simple, right? So now the 5th column, what you have to do is you have to write the previous answer which you have got, right? Same thing you have to write here. Like this, you have got first one for hydrogen, you have got 4.07. Okay. Same way for carbon, you got something 2.02. Okay. Next one for chlorine, 2.02. So what you have to do is you have to divide this, by the least atomic ratio. Okay. What will we do? We will divide this, whatever numbers are there, by the least atomic ratio. Okay. So in this case, which is the least? 2.02. Divide 2.02. Here also 2.02. Here also 2.02. The answer will be here 1. Okay. This will be 2. Okay. This will be 1. Okay. So now what information are we getting? This, not the simplest ratio. This will give us the information for empirical formula. Okay. So basically our empirical formula will be C1H2 and 1Cl. Okay. Basically, like I did not write hydrogen first because normally when you write any compound, right, carbon always comes like we write. Okay, you all are new, right? So it is fine if you all write hydrogen and all first. Okay, accepted. But since like like in your further classes, when you all write any name of the compound, right, you all will know that carbon comes first, followed by hydrogen. Yeah, like CHO will be your aldehyde, then you have your ketones and all carboxylic acids. So basically, carbon is like the backbone of our of any compound, you can say. So because of that, carbon we always write first, okay? But for you all, it is fine if you all write hydrogen also, okay? Because you all are just new to all this. So I wrote CH2Cl, okay? So now calculate the empirical mass, okay? Empirical formula mass. So how will you do? Basically, you have to do it is same, okay? So you have to substitute like one carbon. Carbon will be 12 plus 2 into 1 plus 35.5. Okay. So empirical formula mass will be 49 point. How much are they getting? 5. Okay. Because here, here they have considered that point, meaning 1.008. Like they have considered the whole thing, the atomic mass of hydrogen. They have taken that zero also after the. So because of that, it will be slightly different when I compare it to my book. But here it will be 49.5. Okay. So now there is another formula. Okay. N will be equal to your molecular mass upon your empirical mass. Okay. So what is the molecular mass? We are given in the question. Molar mass is also called as molecular mass. Starting I told you all, right? So how much it is? 98.96. Okay, divided by here we got 49.5. Okay, if you divide, no, it will be 2 point something. How much are you getting? I think you will have to use log, okay? But it will be like, this can be this value, okay? If you all had got something, 2 point, say 1.5 or 2.2, still you will keep it as 2. If you all had got like something as 2.8, then convert it into 3. Okay. So, yeah. So here it is coming as 2. So since we got N as 2, your molecular formula will be 2 into your empirical formula. Since it is N, basically it is N into your empirical. So here N will be equal to 2. Okay. CH2Cl. So how much it will be? C2H4Cl2. Okay, so this will be your molecular formula. Done? Copied? You all are copying? Done? Copying? Now let us take the second one, like second of this type. There you will find a bit of change. Sorry, you all understood, right? You all want me to explain another time? Clear? Okay. Take the next question, okay? Try solving the next question. Huh? That you have to find. Organic, after finding the empirical and molecular formula, you will get whatever compound C. Basically, that is the organic compound. Basically, this is only like pertaining to organic because organic deals with, your halogens, then carbon, hydrogen, nitrogen, sulfur. It is only fixed to some, I think, 5 elements. It's 24th, no? 25th. Hmm? What? Yeah, basically, molecular formula which you get, no, that is your organic compound. 10 upon 7.5 is something 1.3 you are getting. Here, 1.3. This. All I've got 1.3 here. Calculate and see. Okay. So now, since we have got 1.3 here, we can't take this. Yeah, no. But here, like I had said, the down part when you'll do, right? Like when you'll find N, that is your molar mass upon empirical mass. For that number, you can convert basically the last. Okay. But here you can't do anything. Meaning what I meant is that N, no, N is equal to molar mass upon empirical mass, whatever values you get, right? That we can keep, like, suppose if you get less than, yeah, we can basically round it off, okay, for this. But here you can't. Yeah, here it is fixed as in you have to multiply it by a number in order to get a whole number. Yeah, so you have to try that. So suppose if you multiply 2 by 1.3, how much do you get? 2.6. Okay. We have got 2.6. Okay. 2.6, it is like somewhat both the ways, right? Like it can be 2 also, it can be 3 also. It is like somewhere midway. So we can't take 2. Try with 3. 1.3 into 3. It will be 9.3.9. Sorry, 3.9. So this is 3.9, right? It is like just one number ahead. So we can convert this 3.9 into 4. Okay, so this also you have to show. Okay, 1.3 into 3. That will be 3.9. 3.9 is equivalent to 4. Here it will be 3. So 3. All I've got this. All understood why I did that calculation at the end. Any doubt? You want me to explain again? Okay. Still here you have understood. We got 1. We got 1.3. Why did I do this? Also you have understood. Sure, right? Understood. Okay. So now, since we have got 1.3, okay, it is somewhere, it is not close to 1 also, and it is not close to 2 also. Okay, it is somewhere in between, right? 1.3. Okay, so we don't get a clear judgment, okay, of this 1.3, like what to do, whether to keep it 1, whether to convert it to 2. Okay, we don't get a proper judgment, okay, of this. So what do we do is we have to multiply this number, basically this number, because it is in the form of a point, right? Point something. So 1.3, we have to multiply by a number in order to get a whole number. Okay. But the thing is, if you multiply by this, right, 1.3, you also have to multiply by top because we add something, we introduce something new, right? So we can't just add something new to the down part and keep that top part as it is. No, it can't be done. So both the numbers we have to multiply with the same number. So we have to try, okay, like 1.3 multiplied by 2. Okay, if I multiply 1.3 by 2, how much do I get? How much do I get? 2.6, right? Again, I got a number which is like between 2 and 3. Okay, so we can't take this. So try with the next whole number, that is 3. 1.3 into 3 is how much? 3.9, right? 3.9 is close to 4. Okay, so we take 3.9 and we say that it is equivalent to 4. Close to 4. Okay. So since we multiply 1.3 by 3 here, we also multiply by 3, same number on top, by 1. 1 into 3, that will give you 3. Okay. So my empirical formula will be C3H4. Okay. Now I want you all to find the empirical mass.
Empirical mass is
40. Okay, done. So now we have to use this N. N is equal to molar mass upon empirical mass. Okay, molar mass is how much? 80, right? Upon 40. How much? 2. So what will be my molecular
2 into the C3.
formula? 2 into my empirical 6H4. So how much it will come? 6H. Yeah, C6H8. Okay, so now we so basically your formula will be C6H8. That's what I was trying. So you have to balance it with 2. 1, 2, 3, 4. Benzene ring.
No.
Yeah, 8-6. Yeah. Did
No, exit. Something in
one, 4, 5, 6, 7, 8. Okay, so it will be somewhat like this compound. So basically, yeah, 3 double bonds, and then you can balance the remaining hydrogen. You have not come on to the nomenclature. Like first, you have to count the number of whatever carbons. So that will be your parent chain. This you all will study it like further on. So it will be hex 1, 3. Hex 1, 3, 5 in. Somewhat like that. But this like you all will learn the nomenclature. So this you all don't have, but I was just like, I was just curious enough to see whether this compound exists. So it does exist, okay? So basically your organic whatever compound you had said, right? You were asking me see which organic compound. It is this C6H8. It will include some 3 double bonds in between. Yeah, it will be a cyclohexane. What's the time? 6? What's the time? 6, yeah, 6, 7. Actually, I wanted to start like the new chapter, but yeah, we are done with this chapter. So what I'll do, I'll can I just give a gist of the next chapter, like a small okay, I'll just introduce structure of atoms. Okay. Okay. So basically, in our structure, next chapter is structure of atom. Okay. So what you all will study in this chapter is the different theories. Okay. So now starting, okay, like what do we understand by an atom? It is the smallest particle of matter, right? Okay. What?
There is something more smaller than that. They discovered something. Never remember.
Okay, next class then you do a search now. In the next class you can let all of us know. Okay. It is always nice if you can share something new, right? Okay, but till now this chapter was long back, right? So according to here, we speak in terms of chemistry. Okay. So when we speak in terms of chemistry, atom is something like the smallest particle of matter. Okay. So starting they said, okay, atom is the smallest particle of matter. Okay. So then, this different theories came into picture. Okay. For now, okay, suppose if we know, for now, if we consider an atom, what is an atom? Atom it will contain a nucleus. Okay. So basically the nucleus will contain something called as neutrons plus protons. Okay. And we know it also has electrons, but they will be around, okay, like in a ring. So they will be, present in orbitals, okay, and they will revolve around the nucleus, okay. So now if we have a picture of an atom, now we get, this is something, right? This picture we get into mind, like we have something, a nucleus. The nucleus will contain neutrons plus protons, and surrounding it will be electrons, okay. But before this theory came into existence, right, there were many scientists and before hundreds of years ago, Like they were struggling to, like discover what basically is an atom. Okay. So starting like, this like Thomas, like he came with his model. Then Rutherford, he came with another model. So they all were like, proving like, like meaning starting they had no clue like what basically are protons. Like protons, we know that protons are basically positive charge, right? Electrons will be negative charge, and basically your neutrons won't have any charge. So this they did not know, like the scientists earlier did not know. So they wanted to prove basically like what are electrons, what are neutrons, So they came up with their models to prove. So basically in this chapter, you all will learn all the different theories, all models, structures and all, okay? Like from the start to the end of this particular structure, like how they came up to this structure, like the basically the drawbacks, the conclusion, the postulates, the observations. So basically this chapter will deal with all of this. Okay. So this we will start in our next class.